Hello there and welcome to A2 Maths from June 2018, and here we're looking at paper 1, question 7 and integration questions. So for 4 marks then, given that k is a positive integer, that means a positive whole number, this set of symbols here, show that the integral from 3k down to k of 2 over 3k minus 3x minus k with respect to dx is independent of k. Now when it says independent of k, what this means is that k is not in the answer. So when we work out the answer, we shouldn't see any k values in there. It doesn't matter what k is. When you work out this integral, it should always be the same value no matter what k is. So it's independent of k, effectively k is not in the answer. So let's do the integration and work out that k is not appearing in the answer. So we are integrating 3k down to k of 2 over 3x minus k dx. Now in this case here we're going to be using the Lund rule. The Lund rule is if you're integrating a function where the top is the differential or somewhere near the differential of the bottom, then you can use Lund of the denominator. Now remember k is just a number here. Differential of 3x minus k is just going to be 3. So ideally we wouldn't have a 2 on the top, we'd have a 3 on the top. But in maths we can't just cross out 2's and write 3's, we need to somehow have a scale factor adjuster at the front. We would ideally like the 2 to be moved to the front, and we can't just create 3's out of thin air. We can though if we divide by 3 at another point. So what we're going to factor out then is a factor of 2 over 3. The 2 that we've cancelled out moves to the front instead, and the 3 that we've created now needs to be cancelled out by dividing by it at the front. So now that I've set my integral up to use the Lund rule, the differential of 3x minus k is equal to 3, I can now use the Lund rule. It's going to be 2/3. And the integral is going to be Ln of 3x minus k between the boundaries of 3k and k. Okay, so let's now substitute in 3k and k, so it's going to be 2 over 3, and then it's going to be Ln of 3 times 3k, that's 9k minus k. Take away k substituted in, that's going to be Ln of 3k minus k. Okay, let's simplify what we've now got inside the brackets. It's going to be 9k minus k is 8k, so it's going to be Ln of 8k minus 3k minus k is 2k. And now when I subtract two Ln's, I divide the things inside them. So 8k divided by 2k, that's just 4. So the answer to this problem here is going to be 2/3 Ln 4. That's the answer to the problem. Does it have k in it? No, it doesn't have k in it. So therefore this is independent of k, which is independent of k. Okay, so there we are. That's 4 marks for part A. Then moving on to part B, show that the integral of 2k to k of 2 over 2x minus k all being squared dx is inversely proportional to k. So there's going to be some division of k. K is going to appear somewhere on the bottom of a fraction. That's what it means to be inversely proportional to k. So let's work out what we're going to now do. It's going to be the integral from 2k down to k of 2 over 2x minus k all squared dx. Now what I'm going to do in this question here is I'm going to use integration by substitution. I'm going to set u equal to 2x minus k. Now it looks like we've got lots of letters here, but just remember the whole time k is just a number. So what's going to now appear on my integral? It's going to appear from 2k down to k of 2u to the minus 2. That's what it will become if I put it into something that's integrable. If that's a word, u squared on the bottom, that will appear as u to the minus 2 as a scale as an indice. But now I need to replace this dx. So now differentiate my substitution. I'm going to have du by dx equals 2. Remember, k is just a number, so therefore dx is going to equal 1/2 du. So I'll multiply dx onto the side and divide by 2 onto the side. So this is going to be times by 1/2 du. So therefore I can cancel out these 2's there and there. Remember, these 2k and k values are x substitutions, so I'll substitute that back into the x position at the end. So now I need to integrate u to the minus 2. Well, how do I do that? That's going to be increasing the power by 1. So now it's u to the minus 1. And then dividing by that power. So it's going to be minus u to the minus 1. In between the x boundaries of 2k and x equals k. So now substituting in u back in, it's going to be minus 1 over 2x minus k in between the boundaries of 2k and k. Let's now move up to the top right of the screen. Substituting in 2k into my function, I'm going to have minus 1 over 4k minus k. And then it's going to be minus substituting in k, 1 over 2k minus k. Okay, so now we're going to have to simplify this together. It's going to be minus 1 over 3k, double negative, that will be plus 1 over k. So now putting a 3 on the bottom and a 3 on the top, this is now going to turn into 2 over 3k as the final answer, which does have k on the bottom of a fraction, so this is inversely proportional to k. Okay, so don't be shy of the way the question's been phrased. Work out the integral, and then hopefully you should present itself to you in a sensible way that would make sense with what you're trying to show. So 2 over 3k, that is inversely proportional to k. K is on the bottom of a fraction. So there we are, that's the answer to question 7 then. Quite a tricky two sets of questions there for 7 marks. Let's now move on to question 8.